Hi everyone, this is Aman Kumar. Welcomes all of you at Brilliant Academy. In today's lecture, we are going to learn our next chapter, that is triangles. In this chapter, we study two things. First one is Thales Theorem, which is also known as Basic Proportionality Theorem, and second one is Similarities of Triangles. Okay, so let's start our lecture. Now see our first topic, Thales Theorem, which is also known as Basic Proportionality Theorem. This theorem said what? If a line parallel to one side of a triangle and intersect other two sides at distinct point, then this line divides the other two sides in same ratio. When a line parallel to one side of a triangle and intersect other two sides at distinct point, then this line divides other two sides in the same ratio. Now look, suppose I have a triangle ABC. This is my triangle A, B and C. Now look, this is a line DE which is parallel to side BC. This line DE is parallel to side BC and this line intersect AB at point D and line intersect AC at point E. Then by Thales theorem or BPT theorem, if DE parallel to BC, then by BPT theorem AD upon DB is equals to AE upon EC. Other two sides are divided in the same ratio. So when DE parallel to BC, then AD upon DB is equals to AE upon EC. Understood? Let's see one more time. What is Thales theorem or basic proportionality theorem? When a line is parallel to one side of a triangle and intersect the other two sides at distinct point, then this line divides the other two sides of a triangle in the same ratio. That is AD upon DB is equal to AE upon EC. Okay. Now we move towards our next topic, that is proof of BPT. Okay. But before seeing the proof of BPT, first we see how we find the area of a triangle. Look, this is my triangle ABC. Now I have to find the area of this triangle. Then what I do? We have a formula of area of triangle is equal to half into base into height. This is my formula. I apply this formula in this triangle and I get the area. Now, but the question is from where I take height? From how I take height? Now look, what is height? Height is what? Height is a perpendicular drawn from opposite vertex of the base. Look, suppose I take BC as base, side BC as base, then my height is a perpendicular drawn from opposite vertex of the base. So opposite vertex of base BC is A vertex. So I draw a perpendicular from A to the base. Then this AL is my height for this triangle. When I take side BC as base, then I draw perpendicular from opposite vertex of BC, that is A, from A. Then AL is my height and this is base. So area is what? Area is equal to half into base BC into height is AL. Now suppose I take side AC as a base. I take side AC as base. Then my height is what? Perpendicular drawn from opposite vertex of the base. So opposite of side BC is B vertex. So I draw perpendicular from B. Then this is BM. Then in this case BM is my height. When base is BC, then area is what? Half into base BC into height is BM. BM. Okay. Now I take AC as base. AB as base. Here this is AC. Okay. Now I take AB as base. Then my height is what? Perpendicular drawn from opposite vertex. Then opposite of AB is C. Then this is my height CN. So when base is AB, then area is what? Half into base is AB into height is CN. Okay. I hope you understand how to find the area of triangle. We have the formula half into base into height. So from where we take height is what? A perpendicular drawn from opposite vertex of the base. So when I take base BC, then my height is from opposite vertex, that is A. So height is AL. The formula is half into base into height, then area is this one. When base is BC, then area is half into BC into AL. When my base is AC, then area is what? Half into AC, base is AC, then perpendicular is height is BM. Okay, so BM. When base is AB, this side is base, then my height is perpendicular from opposite vertex, that is from CN. So area is half into AB into CN. Okay. Now we move towards the proof of BPT. Look, I have this triangle ABC, this triangle ABC, and this is the line DE, which is parallel to side BC. Okay, BPT theorem is what? Line which is parallel to side any one side of a triangle, then this line divides other two sides in same proportion or same ratio, which means AD upon DB is equal to AE upon EC. We have to prove this. So from here, what is given? Given is DE parallel to BC. Okay, and what we have to prove? So to prove AD upon DB is equals to AE upon EC. Now for this proof we have to do some construction. Okay, so first construction I do is I join BE, then I join DC. So first construction, join BE and DC. After this, we have to do one more construction. First, I draw a perpendicular from D to side AE. Okay, I name it as MDM. Then after this, again I draw perpendicular from vertex E to the side AD. This is N. So here draw perpendicular DM perpendicular to AE and EN perpendicular to AD. Okay, we have to do this construction. Now we move towards our proof. Now look, we have one triangle ADE, okay, and we have one triangle BDE. We have two triangles ADE and BDE. Now I have to find the area of triangle AD. Area of triangle ADE, and I take base AD. Okay, area of triangle AD is half into base into height. Now I take AD side as base. Then my height is what? EN. EN is height. Height is the perpendicular drawn from opposite vertex of the base. So base AD. Then opposite vertex is E, and EN is perpendicular. Then height is EN and base is AD. Now proof. So area of triangle ADE. I take base as AD. So half into base AD into area is height EN. Now this is the area of triangle ADE. ADE. Now we have to find area of triangle EDB or BDE. So area of, again area of triangle BDE. Now for this triangle BDE, I take DB as base. DB as base. Now DB as base, which means height is perpendicular from opposite vertex. So opposite vertex of DB is E and perpendicular is EN. So for this height is EN. So half area is half into base is DB. Height is EN. Okay. This is the area. Now we have to divide this. Then area of triangle ADE upon area of triangle BDE is equal to what? Half into AD into EN upon half into DB into EN. EN is cancelled, half is cancelled. Then what we left? Area of triangle ADE upon area of triangle BDE E is equals to AD upon DB. Now this is my equation first. Now after this, again I find the area of triangle ADE. Now in this case I take AE as base. When I find first time area of triangle ADE, then I take AD as base. Now at second time I take AE as base. Okay. Then again area of triangle ADE is equal to half into base. I take AE as base. So AE, and height is what? Perpendicular from opposite vertex. So AE perpendicular is DM. Opposite vertex of AE D, and perpendicular is DM. So height is DM. Here DM. Now again I take area of which triangle? EDC or CDE. So area of triangle CDE, half into base. Triangle CDE, I take base as EC. So base is EC into height. Height is perpendicular from opposite vertex. So opposite vertex of EC is D and perpendicular is DM. So again for this triangle height is DM. So height is DM. Now I divide area of these two triangles. So area of triangle ADE upon area of triangle CDE is equals to half into AE into DM upon half into EC into DM. Now DM is cancelled, half is cancelled. So what we left? Area of triangle ADE upon area of triangle CDE is equals to AE upon EC. We have left AE upon EC. Now look, triangle BDE and triangle CDE. Triangle BDE and triangle CDE. These two triangles lie between same parallel side DE and BC. Triangle BDE lie between DE and BC. Triangle CDE also lies between side BC and DE. That's why area of these two triangles BDE and CDE are equal. So I write here area of triangle BDE is equals to area of triangle CDE. Why? Because they both lie between same parallel side. Okay. Now look, when the area is same, then I write area of triangle BDE in place of area of triangle CDE. Okay. This is my equation second. Now in equation second, area of triangle ADE upon area of triangle BDE. In place of CDE, I write BDE. Why? Because area of triangle CDE and BDE are equal. So area of triangle ADE upon BDE is equals to AE upon EC. AE upon EC. This is my equation third. Okay. Now look equation first and equation third. Area of triangle AD upon BD is equal to AE upon EC. Area of triangle AD upon area of triangle BD is equal to AD upon DB. LHS and LHS are equal. That's why RHS is also equal. So from, I write it here. From equation first and equation third, AD upon DB. AD upon DB is equals to AE upon EC. AE upon EC. Now we have to prove this. AD upon DB is equal to AE upon EC. AE upon EC. So our BPT theorem is proved. Let's see one more time what I do. We have to prove that this line DE, which is parallel to BC, is divide AB side and AC side in the same ratio. Which means we have to prove AD upon DB is equal to AE upon EC. We have given DE parallel to BC. Now I do some construction. First I do join BE and DC. I join BE and DC. Then after I draw one perpendicular which is DM perpendicular to AE, DM perpendicular to AE, and EN perpendicular to EN perpendicular to AD. Now after this I find the area of triangle ADE by taking AD as base. So area of triangle ADE is half into AD is base, height is EN. Height is what? Perpendicular from opposite vertex of the base. So here is EN. Now then after I find area of triangle BDE. Area of triangle BDE, half into, I take base as BD and height is opposite vertex, perpendicular from opposite vertex. So opposite is E. So EN is height. So half into DB into EN. Now after this I find the ratio of these two areas. So ADE upon area of BD is equals to half into this and this. Half and EN cancel. Then we have AD upon DB. Area of ADE upon area of BD is equals to AD upon DB. This is my equation first. Then again I find area of triangle ADE by taking AE as base. Okay, so AE as base, the height is DM. DM is perpendicular from opposite vertex of AE. Then area of triangle CDE. CDE by taking EC as base. So half into base, DM is height. Then again I take ratios. So area of ADE upon area of CD is equal to this. DM cancel, half cancel. Then what we left? Area of triangle ADE is equal to upon area of triangle CD is equal to AE upon EC. Now look, triangle BDE and CDE, triangle BDE, CDE, these two triangles lie between same parallel side DE and BC. That's why area of these two triangles are equal. So area of these two triangles are equal. Now I put in equation 2 in place of CDE I write BDE because area of triangle CDE is equal to area of triangle BDE. So I put in equation 3 area of triangle ADE upon BDE in place of CDE is equal to AE upon EC. Now from first and third LHS are equal of first and third. That's why RHS of first and third are also equal. So from 1 and 3 AD upon DB is equal to AE upon EC. It is proved. Okay. Now next we see converse of basic proportionality theorem or converse of BPT. This theorem said what? If a line divides any two sides of a triangle in same ratio, then this line is parallel to the third side. BPT theorem said what? If a line is parallel to any one side of a triangle and then this parallel line divides other two sides in the same ratio. Converse said what? If a line divides any two sides of a triangle in the same proportion or same ratio, then this line is parallel to the third side. Okay, look, this is my triangle ABC and this is line DE. When this line DE divides AB and AC side in same ratio, which is AD upon DB is equals to AE upon EC, then by converse of BPT we write DE is parallel to side BC. Understood? When a line divides any two sides of a triangle in same proportion or same ratio, then by converse of BPT, DE is parallel to BC. Okay, let's practice some questions related to BPT. So our first question is, we have two figures, first and second, and in these two figures we have line DE is parallel to side BC, then we have to find EC, this EC in first figure and AD, this AD in second figure. Okay, well, first we see our question first. Now look, this is a triangle in which DE is parallel to BC, then by BPT what we write? DE is parallel to BC, then by BPT AD upon DB is equals to AE upon EC. Okay, so now look, AD is what? AD is 1.5 upon DB is what? 3. AE is what? 1 centimeter, 1 upon EC. So from here EC is 1.5 multiplied with EC and 3 into 1. So EC is what? 3 upon 1.5. Okay. Now EC is equals to 3 into 10 upon 15. When we remove the point, we take 1 0, that is 10. So 3 5 5 2. From here EC is 2 centimeter. Okay. Now see second one. In this DE is parallel to BC, then by BPT AD upon BD or DB is equals to AE upon EC. AE upon EC. Now we have to find AD. So in place of AD, we write AD. Now DB is what? 7.2 centimeter. 7.2 is equals to AE is what? 1.8 and EC is 5.4. So 1.8 upon 5.4. So now from here AD is what? AD is 1.8 into 7.2 upon 5.4. Now 1.8 into 3, that is 5.4. Now from 3, 7.2 is cancelled out. 3 to 6 points, 3 4 12. So in second figure AD is 2.4 centimeter. Okay, let's see one more time. We have two figures or we have two triangles in which DE is parallel to BC. So in first we have to find EC and in second we have to find AD. So when DE is parallel to BC, then by BPT, AD upon DB is equals to AE upon EC. AD is 1.5, DB is 3, AE is 1, EC we have to find. So from here EC is 2 centimeter. Now in second figure DE is parallel to BC, then by BPT AD upon DB is equals to AE upon EC. We have to find AD. So I write here AD, DB is 7.2, AE 1.8 and EC is 5.4. Now after calculation AD is what? 2.4 centimeter. Okay. Now we see our next question. Question is what? In given figure DE is parallel to AC. Look this figure. DE is parallel to AC. Where is DE? DE. This is DE is parallel to AC. Okay, this DE is parallel to AC. Next thing is given DF is parallel to AE. DF. This is DF is parallel to AE. This is okay. Then we have to prove what? BF upon FE is equals to BE upon EC. So first I write what is given. Given DE is parallel to AC and DF is parallel to AE. Then we have to write what we have to prove. So to prove is what? BF upon FE, DF upon FE is equals to DE upon EC. Okay. Now let's prove. So proof. First we look BF and FE. BF and FE lies in which triangle? So look, BF is here. This is BF and this is FE. BF and FE lie in triangle ABE. BEA. This triangle ABE. In this triangle, BF and FE lies. So we consider triangle A, B and E. Look, A, B and E. This is triangle A, B and E, and in this DF, this is DF is parallel to AE. So now look, this is triangle ABE. In this triangle, DF is parallel to AE. Then by BPT, what we write? BF upon FE. BF upon FE is equals to BD upon DA. Okay, this is my equation first. Now BE and EC, BE and EC. Now again we look in which triangle BE and EC lies. So BE is here, BE and EC is here. Now BE and EC lies in triangle ABC in bigger triangle. So now we consider in triangle ABC. ABC. Triangle A, B and C. This is triangle A, B, C. BE and EC. So in this triangle, this BE is parallel to AC. In triangle ABC, DE is parallel to AC. Then by BPT, what we write? BE upon EC. BE upon EC is equals to BD upon DA. Okay, this is my equation second. Now look first and second. In equation first and second, RHS BD upon DA is equals to BD upon DA. So from 1 and 2, now I write it here. From 1 and 2, what we write? RHS are equal, then LHS and LHS is also equal. So from 1 and 2, BF upon FE is equals to DE upon EC. This is proved. Okay, let's see one more time what we have. We have a triangle ABC. in this triangle, DE is parallel to AC. DE, this is DE, is parallel to side AC, and DF, this is DF, is parallel to AE. Then we have to prove DF upon FE is equal to BE upon EC. So first I read what is given and what we have to prove. Then first step I look BF and FE lies in which triangle. So I find BF and FE lies in triangle ABE. Now look triangle ABE. In this triangle ABE, DF is parallel to AE. Then by BPT, I write BF upon FE is equals to BD upon DF. BF upon FE is equals to BD upon DF. Now, second, I look BE and EC. In which triangle BE and EC lies? So I find BE and EC lies in triangle ABC. So I make a similar figure APC, and this triangle DE is parallel to side AC. Then by BPT, BE upon EC is equals to BD upon DA. This is my equation second. Now look equation first and second. RHS of these two equations are same. Then LHS is also same. When RHS is same, LHS is also same. So from first and second, DF upon FE is equals to BE upon EC. Okay. Now let's move towards our next question. So next question is, in figure DE is parallel to OQ. This is my figure of triangle PQR. In this figure, DE is parallel to OQ. DE. This line DE is parallel to OQ and DF is parallel to OR. Where is DF? This is DF is parallel to OR. Then we have to prove EF is parallel to QR. This EF is parallel to QR. We have to prove this. Okay, this is O. So first we write what is given. So what is given? DE is parallel to OQ and DF is parallel to OR. This one is given. Then after we have to write what we have to do, proof. So to prove is what? EF is parallel to QR. We have to prove this. Now let's prove. First thing is given, DE is parallel to OQ. Now look in which triangle DE lies. DE lies in triangle POQ. In triangle POQ, DE is parallel to OQ. Then by BPT, PD upon DO is equal to PE upon EQ. So first we consider in triangle POQ, DE is parallel to OQ. Then by BPT, what we write? PD upon DO, PD upon DO is equals to PE upon EQ. Okay. Now next thing is what given? DF is parallel to OR. DF is parallel to OR. This is given. Now look, DF and OR lies in which triangle? POR. In POR triangle, DF is lies and is parallel to OR. So we consider in triangle POR, this triangle DF is parallel to OR. Then by BPT, what we write? That PD, this PD upon DO, PD upon DO is equals to this PF upon FR. Okay, PF upon FR. Now let us assume this is my equation first and this is my equation second. So now from first and second, what we write? From equation first and second, what we write? PD upon DO, PD upon DO. LHS is equal, then RHS is also equal, that is PE upon EQ and PF upon FR. So PE upon EQ is equals to PF upon FR. PF upon FR. Now look, PE and EQ. PE is where? PE. PE is here and EQ is here. PE upon EQ is equals to PF upon FR. So PE and EQ, PF and FR. Then by converse of BPT, EF is parallel to QR. Then by converse of BPT, we write EF is parallel to QR. This is we have to prove. Now this one is proved. Okay, let's see one more time what we have. We have a triangle PQR. In this triangle, ED is parallel to OQ. This is given, and DF is parallel to OR. This one is given. Then we have to prove EF is parallel to QR. First, I consider triangle POQ. Triangle POQ. Why? Because in this triangle, BE is parallel to OQ. This one is given. So from this by BPT, I write PD upon DO is equal to PE upon EQ. Then I consider triangle POR. In this triangle, DF is parallel to OR is given. Then by BPT, PD upon DO is equal to PF upon FR. Now this is my question second, this is my question first. So from first and second, I see LHS are equal. Then RHS is also equal. So PE upon EQ is equal to PF upon FR. Now look, PE is this one, EQ is this one, PF is this one, and FR is this one. So this by this are equal. Then by converse of BPT, EF is parallel to QR. This we have to prove. Okay. Now let's see our next question. In triangle PQR, PS upon SQ is equal to PT upon TR. This is my triangle PQR. In this triangle, PS upon SQ is equal to PT upon TR, and angle PST, this angle, and PRQ, this angle are equal. Then we have to prove that this triangle PQR is an isosceles triangle. Now look, what is the isosceles triangle? When opposite angles of a triangle are equal, then the triangle is known as isosceles triangle. So we have to prove this angle is equal to this angle. Okay, R equals to Q. When we prove that angle PRQ is equal to angle PQR, then we say yes, this triangle PQR is an isosceles triangle. So now look, first I write what is given. Given is what? PS upon SQ is equals to PT upon TR, and angle PST is equals to angle PRQ. Now what we have to prove? Angle PQR is equals to angle PRQ. When we prove angle PQR and angle PRQ are equal, then this triangle is an isosceles triangle. That's why PRQ is equal to PQR. Now let's move towards proof. First thing is given, PS upon SQ is equal to PT upon TR. So I write PS upon SQ is equal to PT upon TR. This is given. So from this, by converse of BPT, ST is parallel to QR. So by converse of BPT, ST is parallel to QR. ST is parallel to QR. Now look, when ST is parallel to QR, then angle PST is equal to angle PQR, corresponding angles. So here ST is parallel to QR, then angle PST is equal to angle PQR. Why? Corresponding angle. Okay. Now PST equals to PQR. PST is equal to PQR, and one more thing is given, that angle PST is equals to angle PRQ. This one is given. PST is equals to angle PRQ. This is given. Now look, PST equals to PRQ and PST also equals to PRQ. Then from these two, LHS are equal. So RHS are also equal. Therefore, angle PQR is equal to angle PRQ. We have to prove this PQR PRQ. Now, when these two angles are equal, then triangle PQR is an isosceles triangle. Proof. Let's see one more time. We have a triangle PQR. In this triangle, PS upon SQ is equal to PT upon TR is given, and one more thing is given, that angle PST is equal to angle PRQ. Then we have to prove triangle PQR is an isosceles triangle. So for isosceles triangle, opposite angles are equal. That's why right here we have to prove angle PQR is equal to angle PRQ. When we prove these two angles are equal, then we say this triangle PQR is an isosceles triangle. So now look, first thing, this one is given PS upon SQ is equals to PT upon TR. Then by converse of BPT, I write ST is parallel to QR. Okay. And then after, when ST is parallel to QR, ST is parallel to QR, then this angle and this angle are equal by corresponding angle. So PST is equal to PQR, corresponding angle. Now PST is equal to PRQ. This one is given. So from this, PST equal to PQ1 and PST is also equal to PRQ. Then these two are also equal. Therefore PQ1 is equal to PRQ. PQ1 is equal to PRQ. Now these two angles are equal. Then our triangle PQR is an isosceles triangle. Okay. Now let's move towards our next question. Question is what? Using BPT theorem, prove that a line drawn through the midpoint of one side of a triangle is parallel to the another side, bisect the third side. Look, we have a triangle. Suppose I have a triangle, this A, B and C. Then I draw a line through the midpoint of one side. Suppose I draw a line from midpoint of side AB. This midpoint is D. Is parallel to the another side. Then we have to prove it bisect the third side. So I draw a line and it intersect the third side at point E, and this line DE is parallel to side BC. Then we have to prove that this line DE bisect the third side, which means we have to prove AE is equals to EC. Okay. So now look, first I read what is given. In this figure given that DE is parallel to BC and D is midpoint of side AB, which means D is midpoint, then AD is equals to DB. This is given. Now what we have to prove? We have to prove that this line DE bisect AC side, which means we have to prove AE is equals to EC. AE is equals to EC. Now let's move towards proof. Now look, when DE is parallel to BC, then by BPT, what we write? AD upon DB is equal to AE upon EC. If DE is parallel to BC, then by BPT we write AD upon BD, AD upon DB is equals to AE upon EC. Okay. Now look, the ratio of AD and DB is 1. Ratio of AD and DB is 1. Why? Because AD and DB is equal. I solve it here. Ratio of AD and DB is 1 because AD is equal to DB. This is given. When AD and DB are equal, the ratio is 1. So look here. AD upon DB is equals to AE upon EC. Now AD and DB is 1, then 1 is equals to AE upon EC. Why 1? Because AD is equals to DB. Now look, this EC goes this side, then it will become AE is equals to EC. We have to prove this. AE is equals to EC. Okay, when AE is equals to EC, which means E is the midpoint of AC and DE bisect EC. But this is equal, then E is midpoint of AC, which means DE bisect the side AC of triangle ABC. Okay, let's see one more time what we have. We have a triangle ABC in which DE is parallel to BC and D is the midpoint on side AB. Then we have to prove that this DE line also bisects side AC using BPT. So first I write what is given. Given is DE is parallel to BC and D is midpoint of AB, which means AD is equal to DB. These are given. Now we have to prove DE bisect AC, which means we have to prove AE is equal to EC. Now let's prove. If DE is parallel to BC, DE is parallel to BC, then by BPT, AD upon DB is equal to AE upon EC. Here AD upon DB is equal to AE upon EC. Now AD upon DB is equal to AE upon EC. AD upon DB is 1. Why AD upon DB is 1? Because AD is equal to DB. That's why when they are equal, this is cancelled out by 1. So AD upon DB is 1 here. Reason AD upon AD or DB are equal. Now this EC goes this side, then it becomes AE is equal to EC. We have to prove AE is equal to EC. When AE is equal to EC, which means E is the midpoint, and when E is the midpoint, which means DE bisect the side AC of this triangle ABC. Okay. Now let's move towards our next question. Question is what? The diagonals of a quadrilateral ABCD intersect each other at point O such that AO upon BO is equal to CO upon DO, then so that ABCD is a trapezium. Look, this is a quadrilateral ABCD in which diagonal AC and BD intersect each other at O such that AO upon BO is equal to CO upon DO. Then we have to prove that ABCD is a trapezium. Now remember what is the property of trapezium? When one pair of parallel side of a quadrilateral, when one pair of side of a quadrilateral are parallel, then we said this quadrilateral is a trapezium. So for proving this is trapezium, we have to prove that AB is parallel to DC. When we prove AB is parallel to DC, then we say that ABCD is a trapezium. So for this, first I write what is given. Given is AO upon BO is equals to CO upon DO. What we have to prove? DC is parallel to AB. When we prove DC is parallel to AB, then ABCD is a trapezium. For this, we have to do some construction. Construction is what? We have to draw EO, which is this EO, which is parallel to AB. We have to draw EO is parallel to AB. So draw EO which is parallel to AB. Now let's move towards proof. Now see this triangle DAB, triangle DAB. In this triangle EO is parallel to AB. Then by BPT, DE upon AE is equal to DO upon BO. So now in triangle DAB, we have EO is parallel to AB. Then by BPT, we write DE upon AE is equals to DO upon BO. This is our equation first. Now look, we have given AO upon BO is equal to CO upon DO. We have AO upon BO is equal to CO upon DO. Now we do cross multiplication. Here AO multiplied with DO, then from here we get AO and multiplied with DO is equal to CO multiplied with BO. Now AO, we take this BO in this side, then this will become AO upon BO is equals to, we take this CO at this side, so AO upon CO is equals to BO upon DO. Now we do reciprocal of both LHS and RHS. After reciprocal, we get CO upon AO is equals to DO upon BO. This is DO upon BO. This is my equation second. Now look equation first and second. Equation first is DE upon AE is equals to DO upon BO. Equation second is CO upon AO is equals to DO upon BO. Now look, LHS of these two equations are equal. So LHS are also equal. So from equation first and equation second, DE upon AE is equals to CO upon AO. CO upon AO. Now look, where is DE? This is DE, this is AE. Is equal to CO. CO is here and AO is here, which means this triangle, triangle DCA, triangle DCA. This is triangle DCA. In this triangle, we have DE and AE, CO and AO. So from this ratio, we said this EO is parallel to DC by converse of BPT. So by converse of BPT, we write EO is parallel to DC is parallel to DC. Now look, when we do construction, EO is parallel to AB. We construct EO is parallel to AB, and here we prove that EO is parallel to DC. Then DC is parallel to AB. Now look, this is parallel and EO is also parallel to AB. Then from these two, we write this is equation third, and this one is equation number 4. Now from third and fourth, we write DC is parallel to AB. We have to prove this. DC is parallel to AB proved. Now look one more time. What we have? We have a quadrilateral ABCD. ABCD in which diagonal of this quadrilateral AC and BD intersect each other at point O in such a way that AO upon BO is equal to CO upon DO. Then we have to prove that this ABCD is a trapezium. First we see what is the property of trapezium. When opposite pair of one side is parallel, then we said this quadrilateral is a trapezium. So we have to prove AB is parallel to DC. When we have proved AB is parallel to DC, then we said ABCD is a trapezium. Now look, first I had what is given, that is AO upon BO is equal to CO upon DO. We have to prove that DC is parallel to AB. So for this, first I draw one construction which is EO. This is EO is parallel to DC. I draw EO is parallel to DC. Sorry, EO is parallel to AB. I draw EO is parallel to AB. Then in triangle DAB, in this triangle by BPT, I write DE upon A is equal to DO upon BO. Then this is given A upon BO is equal to C upon DO. First I do cross multiplication, then I get this one, then I reciprocal this, then I get C upon AO is equal to DO upon BO. This is my question second. Now from first and second, look, RHS are equal, then LHS are also equal. So I write here from 1 and 2, DE upon A is equal to CO upon AO. DE, AE, CO and AO. Now look, DE is in triangle this, DCA, DCA, DE, AE, CO, AO. Then by converse of BPT, I write EO parallel to DC. This is my question third. And EO is also parallel to AB. Then from third and fourth, DC is parallel to AB. Okay. Now let's move towards next part of this chapter, that is similarities of triangles. But before learning similarities of triangle, first we learn what is a similar figure. To look at when two figures are said to be similar when their corresponding sides are proportional. Suppose I have two figures and the corresponding sides of these two figures are proportional or in same ratio, then we say that these two figures are similar. Look at example. Suppose I have a figure this. And I have one more figure. This is PQRS. Now this one is a square ABCD and this PQRS is also a square. Okay. Now according to similar figure, when the sides of both square are proportional, then we say that these two square ABCD or PQRS are similar. Side proportional means if AB upon PQ is equals to BC upon QR. BC upon QR is equals to DC upon SR. DC upon SR is equals to DA upon SP. DA upon SP. Okay. Now look, if AB upon PQ, BC upon QR, DC upon SR, DA upon SP are proportional, or the ratios of these four sides are equal, then in this case we say these two squares are similar. This is the sign of similar. Okay. Then in this case we said square ABCD or square PQRS are similar to each other. Understand? Let's see one more example. Look here. Suppose I have one rectangle. This is my rectangle ABCD, and I have one more rectangle. This is. PQRS. Now look, these two rectangles are different to each other. This is ABCD is smaller and PQRS is a bigger rectangle. But if the ratio of the sides are proportional or in the same ratio, if AB by PQ, BC upon QR, DC upon SR or AD upon SP are equal, or the ratio of the sides are equal or proportional, then in this case we said these two triangles are similar. Okay, then rectangle ABCD is similar to rectangle PQRS. Understood? Now we see what is the similar triangles. So look in the definition. Two triangles are similar when their corresponding angles are equal or their corresponding sides are proportional. Look, suppose we have two triangles ABC and PQR. I have two triangles ABC. This is my triangle A, B, and C, and this is my triangle PQR. PQR. Now we have two conditions for similarities of triangle. First one is when their corresponding angles are equal. When their corresponding angles are equal, which means angle A is equal to angle B, sorry P, and angle B is equal to angle Q, and angle C is equal to angle R. Then in this case we said these two triangles are similar. And one more condition is what? Corresponding sides are proportional, which means if AB upon PQ, BC upon QR, and AC upon PR are equal, then in this case again we said these two triangles are proportional, sorry, similar. So first condition is what? If angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, then in this case triangle ABC is similar to triangle PQR. This is my first condition. When corresponding angles are equal, then two triangles are similar. Second one is what? Corresponding sides are proportional. Corresponding sides proportional with if AB upon PQ, AB upon PQ is equals to BC upon QR, BC upon QR is equals to AC upon PR, AC upon PR. Then again in this case we said these two triangles, then triangle ABC is similar to triangle PQR. Understood? When corresponding angles are equal of two triangles, then in this case we said two triangles are similar. When their corresponding sides are proportional, again in this case we said these two triangles are similar. Understood? Now let's see what are the results we get when two triangles are similar. Now look, when two triangles are similar, when their corresponding angles are equal, then triangle ABC is similar to triangle PQR, or when their corresponding sides are proportional or corresponding sides are in same ratio, then triangle ABC is similar to triangle PQR. These are the criteria for similarities. Now look, when two triangles are similar, ABC is similar to PQR, then by CPST. CPST is what? Corresponding part of similar triangle, just like CPCT. Corresponding part of congruent triangle, same CPST, corresponding part of similar triangle. Then by CPST, what we get? Angle A is equals to angle P, corresponding angles are equal. A is equals to P, B is equals to Q, and C is equals to R. If two triangles are similar, then their corresponding angles are equal. And next thing we get is ratio of the sides are equal, which means AB upon PQ, AB upon PQ, BC upon QR, BC upon QR, and AC upon PR, AC upon PR, okay, are equal. Next thing is what we get is area. Area of triangle ABC upon area of triangle PQR is equals to AB upon PQ square, QC upon QR square, or AC upon PR square. Got it? Let's see one more time. When corresponding angles of two triangles are equal, then in this case two triangles are similar. Second criteria is what? When ratio of the corresponding sides are proportional, then two triangles are similar. Okay. Now, when two triangles are similar, then in this case by CPST corresponding angles are equal, ratio of their corresponding sides are equal, and ratio of their areas is equal to square of the ratio of their corresponding sides. Got it? Now let's move towards our next topic, that is criteria for similar triangles. So our first criteria is what? AAA similarities, that is angle similarities. This similarities criteria said what? If all three corresponding angles of two triangles are equal, then in this case we said these two triangles are similar by AAA, that is angle. Now look here, we have one triangle ABC and one triangle PQR. Now in this case, if angle A is equal to angle P, angle A is equal to angle P, angle B is equal to angle Q. This is angle B is equal to angle Q, and angle C is equal to angle R. This is angle C is equal to angle R. Then in this case, we said that triangle ABC and PQR are similar by AAA, that is angle. Got it? Now let's see our second criteria, which is angle similarities. In this case, only two angles are included. Now look, if any two angles of one triangle are equal to any two angle of other triangle, then these two triangles are similar by angle similarities. Now look here. If any two angles of one triangle are equal to any two angle of other triangle, then these triangles are similar by angle. Now look, I have one triangle ABC and second triangle PQR. In this triangle, I have angle A is equal to angle P and I have angle B is equal to angle R. Two angles of one triangle are equal to two angle of second triangle. Then these two triangles are similar by angle. Now look here in the naming. A equals to P, B equals to R. So if you name this, then triangle ABC. Triangle ABC is similar to triangle which? Angle A is equals to angle P, B is equals to R. That's why I write here PR. Then Q. If I write like this, triangle ABC is similar to triangle PQR, then this is wrong. If I write it like here, then this is wrong. You have to write equal angle at equal pattern. Just like A equals to P, A equals to P. B equals to R, that's why I write here B, then R, then C and Q. Understood? Let's move towards our next criteria, which is SSS similarities. That is side. This criteria said what? If in two triangles, the corresponding sides of one triangle are proportional to the other triangle, then these triangles are similar by SSS. Now look here. I have one triangle ABC and one triangle PQR. Now in this triangle, if AB upon PQ is equal to BC upon QR and AC upon PR, then these two triangles are similar by SSS. Then these two triangles are similar by side. Got it? Now let's check it. AB upon PQ. AB upon PQ is what? AB upon PQ is equal to AB is here 2, PQ is here 4. So AB upon PQ is 2 upon 4, which is 1 upon 2. Okay. Now let's check for BC upon QR. BC and QR. BC upon QR. BC is here 4. QR is here 8. Then again this ratio will become 1 upon 2. Okay. Now let's check for AC upon PR. AC is 3 and PR is 6. So here AC upon PR. AC is here 3, PR is 6. 3 and 6. Then again this ratio become 1 upon 2. Now look. AB upon PQ is 1 upon 2. BC upon QR is again 1 upon 2. AC upon PR is again 1 upon 2. Then the ratio of AB upon PQ, BC upon QR and AC upon PR is equal to 1 upon 2. Then in this case, these two triangles ABC and PQR are similar by SSS. Now again we have to look for the naming. Look here, AB and PQ. So AB upon PQ, BC upon QR, BC upon QR, AC upon PR, AC upon PR. So you have to look for the naming. You have to write the correct naming. Understood? Let's see our next criteria, which is SSS similarities. That is side similarities. This similarity said what? If one angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then these two triangles are similar by SAS, which is side. Now look, suppose I have one triangle ABC and PQR, and in these two triangles, angle A and angle P are equal. Angle A is equal to angle P. One angle of triangle is equal to other one angle. Now in these two triangles, angle A and angle P are equal. Now next thing is what? The sides including these angles are proportional. Sides including these angles are proportional. Now look which side include angle A and angle P, which means angle A lies between which side? In triangle ABC, angle A lies between AB and BC side, AB and AC side. Okay. Now in triangle PQR, angle P lies between PQ and PR sides. Now again look at definition. Sides including these angles are proportional, which means AB, if AB upon PQ is equals to AC upon PR, then we said by two conditions, angle A equals to angle P and AB upon PQ is equal to AC upon PR, then these two triangles are similar by side. So now write it here. If angle A is equal to angle P and AB upon AC, AB upon PQ is equals to AC upon PR, then triangle ABC is similar to triangle PQR. Okay, ABC is similar to triangle PQR. Understood? Let's see one more time. if one angle of one triangle are equal to one angle of second triangle. One angle of one triangle is equal to one angle of other triangle, and sides including these angles are proportional. Then in this case we said these two triangles are similar by SAS. Now look here, I have two triangles ABC and PQR. In these two triangles, angle A equals to angle P. Then after this we look for the sides including these angles are proportional. So look here, in triangle ABC, angle A is between AB and AC side. So I write it here. And in triangle PQR, angle P is between PQ and PR side. So I write it here. Now if AB upon PQ is equal to AC upon PR, then in this case we said by these two conditions, angle and side, that these two triangles are similar by side angle side. So I write it here. If angle A is equal to angle P and AB upon PQ is equal to AC upon PR, then triangle ABC is similar to triangle PQR by side angle side. Understood? I hope you all understood about what is similar figure, what is similar triangle, and what is the criteria for similarities of triangles. Now let's practice some questions related to similar triangles. Now see our first question. Question is what? In figure, Q1 upon Qs is equal to Qt upon PR and angle 1 is equal to angle 2. Then we have to show and triangle PQS is similar to triangle PQR. Look, this is my figure. In this figure, QR upon QR, this one upon QS, this is equals to QT bigger line upon PR, this one, okay, and angle 1 is equal to angle 2 is given. Then we have to prove that PQS, triangle PQS, this one smaller triangle is similar to triangle PQR, this is a bigger triangle. Now let's write first what is given. Given is what? QR upon QS is equals to QT upon PR and angle 1 is equal to angle 2. This is given. Now write what we have to prove. So to prove is what? Triangle PQS is similar to triangle PQR. Now let's prove this. First we see in triangle PQR, angle 1 is equal to angle 2, which means angle 1 is equal to angle 2, which means PR is equal to QP. First let in triangle PQR, in this triangle angle 1 is equal to angle 2, this one is given. Then if 1 is equal to 2, then PR is equal to QP, then PR is equal to QP. Okay, now this is given. QR upon QS is equal to QT upon QR. Now write it here. QR upon QS is equal to QT upon PR. This one is given. Now in place of PR we write QP. In place of PR we write QP because they both are equal. So from here QR upon QS is equals to QT upon QP. Okay. Now this is my question. First, QR upon QS is equals to QT upon QP. Now look, where is QR? QR is this bigger triangle. PQR, QS is in this triangle PQS. QT is in bigger triangle PQR, and QP is in smaller triangle PQS. Okay. And now look, in bigger triangle PQR and PQS, angle Q is common. Okay, so we have two criteria. First is angle and second one is sides are proportional, which means these two triangles are calculated by side angle sides. So I write it here. Now in triangle PQS and TQR, in triangle PQS and triangle TQR, first angle Q is common, so first I write angle PQS is equal to angle TQR, which is common, and the sides which including this angle. Look, angle Q is lies between QS sides and QR side, QS and QP and QT, so they are proportional. So this one is QS upon QR. I reciprocal this because QS is in triangle PQR. That's why I write reciprocal. That is QS upon QR equals to QP upon QT. Okay. Now I use this in this criteria. Now second thing is angle, sorry, side QS upon QR is equals to QP upon QT. This is from first. Now my triangle PQS and triangle TQR are similar. Therefore, triangle PQS is similar to triangle TQR by side angle side. Okay. Now this is proved. Let's see one more time. What is the given? We have triangle PQS. In this triangle, QR upon QR bigger one upon QS is equal to QT is bigger one, and PR. And angle 1 is equal to angle 2 are given. Then we have to prove that triangle PQS, this one triangle, and triangle PQR, bigger one, are similar. So first I write what is given. Given is what? QR upon QS equals to QT upon PR, and angle 1 is equal to angle 2. This one is given. Then what we have to prove? PQ is similar to triangle PQR. Now first I consider triangle PQR. In this triangle, angle 1 is equal to angle 2 is given. Then if angle 1 and 2 are equal, then PR equal to QP. Okay. Now QR upon QS equals to QT upon PR is given. So in place of PR, I write QP here. Okay. Then after this, I reciprocal this ratios. Then QR upon QS become QS upon QR, and QT upon QP become QP upon QT. Now I assume this is my equation first. Then I let in triangle PQS and TQR, which we have to prove similar. Now angle PQS and TQR are common in both triangles and these ratios, and sides which including the angles are proportional. Then these two triangles are similar by side angle side. Understood? Now let's see our next question. Question is what? Prove that CP is equal to AB where CD is perpendicular to AB. We have one triangle ACB. In this triangle, CD is perpendicular on AB, and we have to prove that CP is equal to AB. CP, this side AB, and P is CD side, and A is what? BC side, and B is AB side. So what we have to prove? Prove CP. CP means CP. C is AB side into P is BC side is equals to AB. A is BC side and B is AC side. So we have to prove AB into DC is equals to BC into AC. Now look, in which triangle AB is present? AB is present in ACB triangle. Suppose I make a separate figure of triangle ACB. Now look, AB is present in bigger triangle, that is ACB, and DC. DC is present in smaller triangle, that is ADC. This is A, this is D, and this is C. AD is present in smaller triangle. AB is in bigger, AD is in a small triangle, and BC again is in bigger triangle, and AC is in again AC, present in both a smaller and bigger triangle. So if we similar these two triangles, smaller one that is ADC and bigger one ACB, then I write AB into DC is equal to BC into AC. Look how we do. So in triangle, which one? In triangle ACB, and in triangle ACB, C is right angle. So in this triangle D is right angle. So I write AD then C, ACB, ADC. Now look, right angle, both are 90 degrees. So angle ACB is equal to angle ADC. Reason both 90, and angle A is common in both triangles. So angle A is common. So I write BAC, angle BAC is equal to, now look, B in place of B, C is here. So C, A in place of A, there is A. So I write A. C in place of C is D. So angle CAD. Now these two triangles are similar by angle. Two angles are similar. Sorry, two angles are equal. Then triangles are similar by angle. Symmetric criteria. So therefore, triangle ACB is similar to triangle ADC by angle. Now look, if they are similar, then corresponding sides are proportional. So corresponding side is what? Here is AC, upon AD is equals to CB upon DC. CB upon DC is equals to AB upon AC. AB upon AC. Now, which side we want? AB, DC, BC and AC. AB and DC we want. AB and DC. AB is here, DC. DC is here, BC. Then BC is here and AC is here. So, we want this ratio. Now, let's take here. Then CB upon DC is equals to AB upon AC. Now, what we want? AB into DC. AB into DC. So, we take cross multiplication. Then from here, I write AB multiplied with DC is equals to BC. This is BC into AC. Now AB is what? AB. AB is B. Sorry, AB is C here. So in place of AB, I write C. DC. DC is P. So P is equals to BC is A and AC is B. So this is proved. CP equals to AB. Got it? Let's see one more time. We have a triangle ACB, which is right angle at C, and in this triangle CD is perpendicular on AB. So we have to prove that CP is equal to AB. Now CP is CP. C is here AB side, P is here DC side, is equal to BC into AC. BC, A is BC and B is AC. So for this, first I similar this triangle ACB and triangle ADC. So look here. In these two triangle, first is this is 90 degree, 90 degree. So angle ACB is equal to angle ADC, both 90 degree. Then angle BAC is equal to angle CAD. BAC is equal to CAD. This is common. Right here, common. Look, A angle and angle A, both are common. Then these two triangles are similar by angle similarities. Then if two triangles are similar, then sides are proportional. That's why I write here AC side, AC upon AD, CB upon DC and AB upon AC. Now look which side we want. We want AB, DC, AB and DC. AB is here, DC is here. BC and AC we want. BC is here and AC is here. So now I take only these ratios. So I write here CB upon DC is equal to AB upon AC. Now I do cross multiplication. AB into DC is equal to BC into AC. Now AB is what? AB. AB is C. DC is P. So I write here CP is equal to AB. BC is A. AB is AC is B. So CP is equal to A into B. Okay. Now let's see our next question. Question is what? Prove that area of the equilateral triangle described on the side of a square is half of the area of the equilateral triangle described on its diagonal. Now look, question said what? There is a square and two equilateral triangles are made on this square. First is in side of a square and second one is on its diagonal. Then we have to prove the area of this triangle is half of the diagonal. Look here, suppose I have a square. This is my square. One triangle is described on its side. Look, area of the equilateral triangle described on the side of a square. One triangle is described on the side of a square. Okay, this is one equilateral triangle and second one is described on its diagonal. So diagonal is what? This one is diagonal. So second equilateral triangle is on this diagonal. Okay. Just name it. This is A, B, C, D is my square. First triangle is E and F. Now look, we have to prove that area of equilateral triangle which described on the side of a square is half of the area of equilateral triangle described on its diagonal. Equilateral triangle described on the side is AEB and on diagonal is AFC. We have to prove area of this triangle AEB is half of the area of triangle AFC. Okay. So let's first we consider triangle AEB and AFC. So in triangle AEB and in triangle AFC. Look, these two triangles are similar or not? These two triangles are similar. Why? Because they are equilateral triangle. Look here, equilateral triangle, and in equilateral triangle all angles are 90 degree. Sorry, 60 degree. So these two triangles are similar. So therefore, I write triangle this and this is similar by angle 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 criteria. Okay, all angles are 60 degree of equilateral angle. That's why these two triangles are similar by angle. Now if triangles are similar, then what happens to the area of the triangles? Area of triangle AEB upon area of triangle AFC is what? A square of the proportional side. So look here, AEB and AFC. AEB and AFC. So AE upon AF square is equals to EB upon FC square is equals to AB upon AC square. Now in this three, I pick only one. Which one? Look here. Triangle AEB. I want this AB side and this AC side. So I only pick this ratio. So area of triangle AEB upon area of triangle AFC equals to AB upon AC square. Okay. Now let's assume AB is L. Then this one is also L and L. Why? Because all the sides of a square are equal. So if AB is L, then BC is also L, DC is also L, and AD is also L. Okay. Now look how we find AC. All angle of a square is 90 degree. Then by Pythagoras theorem, h square is equal to p square plus b square, which means this one AC is what? Root over L square plus L square. Then this will become 2 L square under root. So AC is what? Root 2 L. So now in place of AB, I write in place of AB, L in AC is what? Root 2L. Root 2L square. L cancel. So now area of triangle AEB upon area of triangle AFC is what? A square of root 2 is 2. So this is 1 upon 2. Now this AFC goes this side, then this will become area of triangle AEB is equals to half 1 by 2. Now this goes this side, then this is area of triangle AFC. Now this is proved. We have to prove area of triangle which is described on side AEB is on side is equals to half of area of triangle which is on its diagonal. So AFC is on diagonal. Look at AEB is equal to half of area of triangle AFC. Understood? Let's see one more time. Question said what we have in a square in which we have two equilateral triangle which is described on its side and on its diagonal, and we have to prove the area of the triangle which is described on the side is half of the area of triangle which is described on its diagonal. So first I made a figure. This is my square ABCD. One triangle is described on its side, so I take AB side and I make one triangle, and this is equilateral triangle. So all angles are equal. So 60 degree. This is also 60 degree. This is also 60 degree. Now next triangle is described on its diagonal. So diagonal is AC. So AFC is the next triangle which is described on its diagonal, and the all angle of this is again 60 degree because these are equilateral triangle. Now look, these two triangles which is AEB and AFC are similar. Why? Because all angles of equilateral triangle are 60 degree. So angle of this triangle is also 60 degree and angle of this triangle is also 60 degree. Then by angle, these two triangles are similar. Now when two triangles are similar, then ratio of their areas is equals to a square of the ratio of their proportional sides. So area of triangle AEB upon area of triangle AFC is equals to what? Proportional side square. So AE upon AF. Here AE upon AF, EB upon FC, and AB upon CF. We want AB and AC. Okay. So now look here. Area of triangle AEB is equal to area of triangle AFC is equal to what? AB square upon AC square. AB is what? L. I assume the side of a square is L. Then diagonal is what? By Pythagoras theorem, diagonal AC is root 2L. So in place of AB, I write here L and AC is root 2L. L cancel, then 1 upon root 2 square, which means 1 upon root 2 square is 1 upon 2. So area of triangle AEB upon area of triangle AFC is 1 upon 2. Now this AFC goes this side, then this will become area of triangle AEB is equal to half into area of triangle AFC. Okay. Now let's move towards our next question. Question is what? ABC is a triangle and PQ is a line segment intersecting AB at P and AC at Q such that PQ parallel to BC and divides triangle ABC into parts which is equal in areas. Then we have to find BP is to AB. Now look, question said that there is a triangle ABC. So first I draw triangle ABC. This is triangle ABC and PQ is the line segment which intersects AB at P. So AB at P and AC at Q. So this line segment intersects AC at Q and it is given that PQ is parallel to BC. Then we have to find BP is to AB. Okay, BP is to AB. So for this, first you see there is two triangles. First triangle ABC and second triangle is APQ. Okay, so first we consider these two triangles ABC and APQ and we do similar for this triangle. So first in triangle APQ and triangle ABC. Now look, if PQ is parallel to BC, then this angle is equal to this angle, corresponding angle, and this angle is equal to this angle, again corresponding angle. So angle APQ is equal to angle ABC and angle AQP is equal to angle ACB. Both are corresponding angle. Corresponding angle. Then by these two triangle APQ and ABC are similar by angle. Therefore, triangle APQ is similar to triangle ABC by angle similarity. Now, what happened to the area of two triangles when they are similar? Two things happen. First, the ratio of their areas is equal to the square of the ratio of their proportion side, and second one, the area of small triangle upon area of bigger triangle is equal to half, which we see in previous question, which is area of triangle APQ upon area of triangle ABC is equal to half. This is we see in our previous question. Now look, APQ upon ABC is equal to half. Now area of triangle are equal to APQ upon area of triangle ABC is equal to a square of the proportion side. So look, AP upon AB square, this is equal to this. Then in place of this APQ and ABC, I write AP upon AB square. So I write it here, AP upon AB square is equal to 1 upon 2. Now let's see it here. Now this square goes this side and become root. So AP upon AB is equal to what? 1 upon root 2. Okay. Now we have to find BP is to AB. BP is here and AB. So for BP, how we find BP? I subtract AP from AB, then I get BP. So now I solve it here. Now BP upon AB. So BP, in place of BP, what I write? In place of BP, I write AB minus AP upon AB. Now this is AB minus AP. AB minus AP. Then we get BP. So now look at it. AB minus AP. So AB upon AB minus AP upon AB. If we split this, then AB upon AB minus AP upon AB. Now AB is cancelled. This will become 1. Then BP upon AB is what? 1 minus AP upon AB. And look, AP upon AB is 1 upon root 2. So 1 upon root 2. So BP upon AB is equals to 1 minus AP upon AB is 1 upon root 2. 1 upon root 2. Now take LCM. LCM is root 2. So here root 2 minus 1. So BP upon AB is what? Root 2 minus 1 upon root 2. Okay, let's see one more time. Question said what? ABC is a triangle in which PQ is a line segment which intersects AB side at P point and AC side at Q such that PQ is parallel to BC. Then we have to find BP upon AB or BP is to AB. So first you see here we have one triangle ABC and one triangle APQ. So we consider these two triangles APQ and ABC, and in these two triangles P equals to B and Q equals to C corresponding angle. Then these two triangles are similar by angle similarity criteria. Now look, if two triangles are similar, then the area is equals to half, then the ratio of the area is half, which is we see in previous question. So area of triangle APQ upon area of triangle ABC is equals to 1 by 2. Now ratio of the areas is equals to what? A square of the proportional side. So I write here in place of this AP upon AB square. AP is in this small triangle and AB is in bigger triangle. So I write AP upon AB square is equals to 1 upon 2. Now this square goes this side and become root. So AP upon AB is 1 upon root 2. Now look here. We want BP upon AB, not AP upon AB. So for BP upon AB is equals to what? In place of BP, I write AB minus AP. BP is AB minus AP. Then we get BP upon AB. Now I split this. Then AB upon AB and AP upon AB. Now AB is cancelled out, which is 1. So BP upon AB is what? 1 minus AP upon AB. Now the value of this is 1 upon root 2. So I place the value. Then I do calculation. Then we get BP upon AB is root 2 minus 1 upon root 2. Understood? Now here our chapter triangle is over. I hope you all understand about what is Thales theorem, what is similar figure, what is similarities of triangle, and what are the results which we get when two triangles are similar. Okay, and if you found this video helpful, then please like, share and subscribe to the Brilliant Academy. Thank you.